to run this is I'm going to talk to you a bit about advanced analytics from a research perspective, and then I'll hand over to Vicky, who will talk us through some of the practical stuff that we've been doing with analytics in BPP, which is super exciting. So my name's David. For those of you who don't know me, I'm responsible for market intelligence at BPP. And at the moment, that means I spend a lot of my time researching the future of work and future skills. And a lot of the time doing that research means thinking about data and analytics. So for the first 10 minutes of this session, I'm going to talk to you about some of the things that we've been researching at BPP, and I'm going to focus in on analytics there. We're going to be talking about a language for talking about analytics, where we define analytics in a way that's useful to us as educators. Second, we're going to have a think about the different types of analytic professional, by which I mean we're going to think about the tasks that different analytic roles require and how that slots into the work that many of you do. And thirdly, we're going to consider who could use a bit of analytics. Analysts and data scientists are the obvious answers to that question, but at BPP, we do spend just as much time thinking about how traditional roles can use analytics and how we can build analytics into those traditional roles. Before we dive into all of that though, I just want to give you a quick idea of where we're getting this material from. We spend time trying to understand which skills are going to be important for the future, because we're responsible for training the professionals of the future. You know, many of the people that we're training now are going to be in the workplace for the next 40 years at least. So that's why we have roles like mine that are dedicated to researching the future of work and thinking about these skills. And on the screen, you can see some of the sources that we've drawn on to do this work. We've surveyed at this point well over 160 research reports and articles that give a viewpoint from industry experts and commentators on future skills. We have conducted our own data analysis, thanks to the data intelligence team and Vicky's team, of over 6,000 jobs advertised in the UK. We've got economic data from the UK government, machine learning analysis of skills from an organisation called Nesta and Burning Glass, and of course our own specialism at BPP too. We've produced a few reports which you will be getting after this session. You can see them on the right hand side. We've got one on professional services, one on future skills in financial services, and one on future skills in central functions. So before we dive into the content, I just wanted to let you know some of the sources for this stuff, where we're getting it from, and the fact that if you're interested in some of the stuff that we're doing here, you do have more content in those reports which you can take a look at too. We're now going to dive in and we're going to take a look at a language for talking about analytics. Now, what I mean by this is that we really need a common frame of reference when we're talking about analytics, a way that we can all classify analytical work so that we can talk productively about the analytic skills that we require and that specific job roles require. When we talk to employers about analytics, we often come across two challenges. The first is that analytics is pretty difficult to define. Analytics can mean many different things. Just defining it as, you know, analytics is the art of analysing data, that's insufficient, because data can mean innumerable things and analysing that data can mean a whole host of things as well. So just approaching it by saying, well, we're going to talk about analytics, that's quite a difficult thing to do. We also come across the issue that many people have this perception, quite understandably, that analytics is something new. Modern analytic techniques depend upon data that's collected from new sources, stored with new techniques, and there are always new and innovative ways to analyse that data. So what I'm going to start with today is addressing both of these challenges, both of these questions, by thinking about the origin of data analysis. And I'm actually going to turn the clock back 500 years and tell you about an astrologer in Antwerp. But I would ask you all to stick with me, because by the end of this section, we're going to have a useful definition of analytics. And hopefully I'll have convinced you that analytics itself is not new, it's not unknown, it's something that's an evolution of a process that we've been doing for literally hundreds of years. So we're going to start with the 1500s, specifically 1540, where we have an astrologer and a commodity trader called Christoph Kurz. On the left, we've got a picture of Antwerp, but that's unfortunately from 1572, because I couldn't actually turn the clock all the way back to 1540 and find any sort of illustration to help us there. But the reason we're thinking about Christoph Kurz is he was a commodity trader and an astrologer. His basic theory was that he could take a look at the movement of the stars And he could take a look at the prices of pepper, ginger, nutmeg, and cinnamon, and he could see a correlation between the way those two things moved. He could see a movement in the stars, and he could predict that in the future, nutmeg was going to be more expensive, something like that. Now, I'm not suggesting for a moment that Kurz was barking up the right tree here. He wasn't very successful in the end, and I believe he ended up telling fortunes for politicians. But the reason I'm showing you Kurz is because what he was trying to do has some echoes in modern analytics. He was taking two data sets, the movement of the stars in this case, and commodity pricing. And he was saying, look, I can see a relationship, or he believed he could see a relationship between these two things. And he could make a prediction about what's going to happen in the future. He believed, based on these two data sets, he did something called backtesting signals. So I want you to keep Christoph Kurz in mind. We're going to skip forward about 100 years to John Graunt. Now, John Graunt was also a very interesting character. He was one of the first people to be admitted to the Royal Society, and his contributions to the Society ranged from a paper on the number of carp in a pond to finding and supplying macassar poison that the Royal Society could analyse. Now, the reason Graunt was admitted to the Royal Academy is actually because he published the first known mortality table. Graunt was very interested in taking a look at mortality rates in different populations, and he recognised that he could spot patterns that he could use to predict mortality rates in the future. He could see that if you look at the difference between urban and rural populations, they had different mortality rates, different death rates. And his work, about 100 years later, was used by the insurance industry to predict death rates for different populations and then price life insurance. Now, the reason I'm telling you about these two people is when we move through to the modern day and we think about a definition of analytics, thinking about where analytics came from is often a really productive exercise. On the screen, we've got a description, a practical definition of analytics from Gartner, and we often use this. The idea is as we move from left to right, the type of analytics we're talking about becomes more difficult and increases in value. At the lower end, we've got descriptive analytics, where you're using historical data to describe what's happened in the past. The next step up is diagnostic analytics, where you use that historical data to make an inference and to diagnose a situation. The next step beyond that is predictive analytics, where you use all of that past data to say, well, in the future, I believe this is going to happen. And then prescriptive analytics is where you take all of that data and you make a prescription, you recommend a course of action. Now, if you think back to Kurz, he was using descriptive analytics to describe what had happened in the past and then to make a prediction about the future. And his diagnosis of the situation was the stars aligned to commodity prices, which of course is not accurate. Then we've got Graunt, who's using descriptive analytics, a description of the past, to predict what's going to happen to those different cohorts in the future. And then 100 years later, the insurance industry uses prescriptive analytics when they say, well, let's use this life table to price our insurance. Now, a lot of the time when we think about things like machine learning and some of the really impressive stuff that some of the presenters at the DLF talk about, it seems set apart from something as basic as saying, well, this is using data to describe, this is using data to predict. But if you look at machine learning, it's fair to describe a lot of machine learning algorithms as systems that are doing predictive analytics at incredible speed and with vast volumes of data. But if you look at some of those algorithms, they're some of them are based on regression, a technique that's been around for a very long time. Some of the new analytic techniques that we think about in the DLF are often evolutions of analytic techniques that have been around for a very long time. And it's useful to use a framework like Gartner to think about the analytics that we're doing, because it gives us a productive way to think about the work that we do and the skills that we need to do it. So I'd like to end this first section just by having a think about these different types of analytics: descriptive, diagnostic, predictive, and prescriptive, and asking everyone in the call today to have a think about the type of analytics that they might do in their work. I am by trade a market researcher. I spend a lot of my time doing descriptive analytics, and sometimes that steps through to diagnostic analytics. And that's a good framework for me to think about the analytics that I do and the skills that I need to do those analytics. And that's a useful place for us to start. So now we have that framework from Gartner, we've got a starting point. The next step is to start to think about types of analytic professional. When we have this working definition of analytics, we can then step through and start classifying analytic tasks, which is what I'm going to do in a second. Then we can take that further and we can think about the types of analysis that you can perform. And then we're going to consider the kind of tools that you might use for each different type and analytic task. So this here is almost a timeline of analytic work. You might be familiar with it already. It's used in a variety of different contexts. But the basic concept is that as you move from left to right, the type of analytic work you're doing increases gain in complexity. You can see these top 3 items are based on that Gartner model. Early on, you're doing descriptive analytics, diagnostic, and then as you go up, you move into predictive analytics. That's more complex. But then at the far end here, you've also got data collection and data management. And what's really important about thinking about analytics is thinking about the prerequisites for certain types of analytic work. In order to report and do descriptive and diagnostic analytics, you need proper data collection and data management. In order to do more advanced predictive analytics, you need a decent understanding of your data. So you need often to have done that data collection and that basic reporting and descriptive analytics so that you properly understand the data that you're wrestling with. So what we're going to do is we're going to think about different job roles and business functions and how they map to this analytic journey. The first one we could consider is business intelligence. Often business intelligence is working with data that's held by the business and collected by the business and using it to produce reporting and descriptive analytics and sometimes diagnostic analytics. If we think about data architects and data engineers, well, they dedicate most of their time to that early stage, that data collection and data management, doing the foundational stuff that you need before you can do the more interesting and complex tasks. And if you think about machine learning, that's at the far end of predictive analytics. That's using advanced techniques, new software, new algorithms to use all of that data to make predictions about the future in a new and innovative way. Now, if I think about my role as a market researcher, I can map what I do to this model quite easily. I can say, well, often I'll do primary data collection. I'll run a research project, and then I'll use that primary data collected to do reporting and descriptive analysis and sometimes a bit of diagnostic. And very occasionally, depending on the project's demands, I might step through and do some predictive analytics using some traditional statistical methods. I can see myself on this journey. You can also take a look at these different categories and have a think about the types of analysis you might find yourself doing at each stage. So at the early stage, it's all about organizing data, cleaning data, curating databases. Then as you step through, it's more about producing bar, line and pie charts, dashboards, visualizations, stuff that tells you what's going on with that data. Then you move through to regression and cluster analysis for that traditional predictive analytics, and then supervised and unsupervised machine learning at the more advanced end. For each of these stages, you also have different tools. You on the call, you all may recognize some of the tools on this screen. You may use tools at different stages in this life cycle. But the purpose of looking at all of this information is to have a think about the tasks that we do in our roles, to have a think about the types of analysis that we perform, the tools that we use, and the way that these tasks, analysis and tools, which ones we could perhaps introduce to our roles and to our organizations. If you find yourself doing a lot of descriptive analysis and diagnostic analysis and reporting, it might be productive to ask, well, can I predict some things using this data? Are there some skills I can acquire, some things I can learn that would allow me to take this work a little bit further, to explore it a little bit more? So the last thing I want to leave you with is some thinking around who could use a bit of analytics. And this is something that we spend a huge amount of time thinking about at BPP. If you take a look at the demand for data analysts and data scientists, the increase over the last few years has been absolutely remarkable. One of my favorite stats is from the Royal Society's report on the dynamics of data science, and they say that between 2013 and 2018, the demand for data scientists increased by 1,287%. And here we're talking about a data analyst, that data scientist, that dedicated role. That doesn't even count the number of roles that are incorporating data analysis and more advanced analytics into roles that have existed for a very, very long time. Well, one thing that we spend quite a bit of time doing is thinking about the skills that people need in individual roles. And I'm not going to take you through it on this call, but one thing I'd recommend doing afterwards is giving Nesta and their machine learning taxonomy a Google, because they've got this wonderful interactive visualization where you can search different job roles. They've used a machine learning algorithm to crunch through 41 million job ads and take a look at the requisite skills for different jobs. And this is something that we're replicating to an extent at BPP, and we're thinking about, because we need to understand the skills that people need in individual roles and how those skills are changing over time. Everyone ultimately could use a bit of analytics, and this is one of the big conclusions from our reporting. If you take a look at all of the roles on the screen and many more that we've studied, Analytics is one of those future skills that people need to incorporate in those roles and that everyone's thinking about. If you think about HR professionals are actively using analytics to take a look at people data. And they're incorporating that into their organizations, maybe at a different rate to auditors and to accountants who've been using analytics for a very long time. And for them, the deployment of analytics is an evolution of something they've been doing for years. I know that we've got a fair few marketers signed up to this event. And of course, marketing is an area that's absolutely prime for being revolutionized by analytics. And that's actually something that Vicky's going to talk to us about in a second, because some of the work we've been doing at BPP there is really, really exciting. I want to close off with some questions and some things for us on the call to think about. I mean, first, it's productive to think about how you use data at the moment. Do you use it to describe, to diagnose, to predict, or prescribe? And once you know how you're using data, you can ask, well, what sort of analytic tasks am I performing? What tools do I use? And are there new things that I could do to introduce to my role to help my organization? And finally, how do you think analytics is going to change your role in the future? I mean, I've got a prediction about market research and how that's going to change. All of you likely have some thoughts and views about how analytics is going to change your roles in the future. And that's something that we at BPP are actively studying. So hopefully that gives you an idea of some of the stuff that we've been doing at BPP and some of the stuff that we've been researching, which is really exciting. What I want to do now is hand over to Vicky, who's going to talk to you about some of the analytic work that the data intelligence team at BPP are doing. And again, that's super exciting in a different way.
So I'm Viki Walker. I'm the head of data intelligence at BPP. So my team look at everything data analytics and insight, and our main job is turning the vast amount of data that we have into intelligence that the business can use. What we wanted to do today is just show you a couple of examples of how we have applied the skills that David's been speaking about at BPP to solve business problems. So the first case study that we are going to take a look at is marketing attribution. I suppose the problem that we had, or the aim of what we were trying to do, was BPP marketing's team's aim was to make our marketing as effective as possible and get the highest return on investment from all of our marketing activities and channel. So just a quick definition of attribution here. Attribution is the action of regarding something as being caused by a person or thing. More specifically, in marketing attribution, it is the action of assigning value to each touch point or interaction that contributed to a customer outcome. So in, I suppose, the most common terms, that would be allowing us to actually assign a revenue value into each touch point that a customer has before they purchase with us, or in our case, by education. So attribution allows us to move from gut feeling of what is working to actual data-driven decisions by using analytics. It allows us to assess channels and activities holistically, so not just, I suppose, looking at one activity and how did that perform, but actually look at the whole journey and understanding the return on investment that we get at each stage. In a world where marketing channels and customer needs are becoming more diverse and complicated, so is attribution. So this is the type of, I suppose, analytics in terms of actual modelling. This is what attribution kind of tends to look like. So attribution is about applying rules, and the rule-based models are not a total version of the truth. They are a shape applied to events which best suit the strategy and needs of a business. So those of you that are coming from a marketing background, hopefully this is something that's quite familiar. Those of you that aren't, the idea is that if you had 5 touch points as a customer before you go to purchase, not just talking about education here, companies will look at those 5 touch points and try and work out how much they've spent on the touch points and how that spend should be attributed. So some people will say, well, actually, let's just, they spent £1,000 with us, let's just put that all on the first thing that they did with us. Or actually, let's put that all on the last thing that they did with us. So that's first and last click. There's also the approach of saying, right, we'll just split it equally. There's been 5 interventions, so just split that revenue equally. Then got position-based, which is about, I suppose, putting rules in terms of what percentage do you want to apply based on the position of the interaction. Time decay is the idea that you want to give the most recent the most amount of value, but you do want to attribute some of it back. And then data driven is the nirvana, I suppose, in terms of actually allowing models like a shapely value model to determine the value, rather than us determining what shape and value we should be putting on each interaction. Google has led the way for attribution, as we would probably all expect, but traditionally they built models that very much serve a online retail-based company. So their attribution actually, historically, their most used attribution looks at last click for a period of just 45 days. Now, BPP, that doesn't work very well for us because we have consideration phases of up to 18 months in our university. You know, they're big decisions about where your education comes in a university programme, and therefore a 45-day window wasn't accurately reflecting what our customers were doing before. So we had made a strategic decision to actually build the skills internally to build our own attribution model. What did attribution look like for us? A lot of data in our systems, a beautiful diagram there, which I'm sure a few of you are, have other data models and systems that look very similar. So we did a lot of work in terms of those skills that David was talking about: data cleansing, data collecting, actually connecting all of our different systems, whether it be Google Analytics or actually kind of student management systems, to make sure that all of our data was in a good place in terms of being able to then apply attribution to it. It is a lot of hard work, and my team did an amazing job pulling that together using those skills that we've talked about. The second part is then applying the model. This is a part that took us a long time because there's no quick win in terms of knowing which model suits your business. You really do have to understand your business to know which model to apply. So we ended up going with a mirrored model. As I say, that works for us because we have such a long conversion period, but we interact with our students. We decided to go for that mirrored weighting because it fit our business strategy, and that is really the key in terms of which model to pick. Then the third thing that we did was about making sure that we had the insight and measurement that could then be communicated back to the marketing team. So making sure that we had the right visualization skills within the teams, the right storytelling, so that actually this wasn't just something that we created and had an attribution model, but actually we were able to then communicate it back so that we could take action and make sure that our marketing was as effective as possible. So once we've done all that work, what it was the benefit of attribution? So we have so brilliant journey understanding now, stitching all of those interaction points together. We now understand our customer journey in terms of what they do before they come to us. We are now able to measure goals and performance based on those journeys and the attribution model that's available. And that allows us to make quicker and smarter decisions in marketing. So making sure that we're investing in the right places. So going back to David's model, at the minute we are just about to bring in some predictive measures that can actually then be prescriptive, because not only do we want to be able to say this is what happened in the past, but we can start using our attribution for recommendation models in the future in terms of where we should be investing our money into the right channels and the right activity. So the second case study that we wanted to quickly go through is predicting student success. So at BPP, one of our main key performance indicators and what we are driving to do as a business is about making sure that our students are successful in their education and are passing their exams. So the business came to us with that: how can we use predictive modelling and analytics to improve our student pass rates? So just going back to a couple of definitions here. The predictive model, a process that uses data mining and probability to forecast outcomes. Each model is made up of a number of predictors, which are variables that are likely to influence future results. So what did that mean for us at BPP? That meant that we wanted to use lots of historical behaviour and characteristic data to predict the future likelihoods of students passing their exams. So the first thing that we looked at was actually, what did predictive modelling look like? And again, when we started looking at this as a team, what we wanted to make sure was that we had the right skills within our team to be able to do this kind of analytics and exercise to add business value. So we use this kind of modelling approach to make sure that we define the objective. Again, my biggest, I suppose, recommendation in all analytics is to really understand what you're trying to achieve and make sure that it's got a business benefit. My team will quite happily run for the shiny things, the new technology that comes in, the things that look really fun to get hold of, and that's great. And we do obviously encourage that, but what we also need to make sure is that there is a direct business impact. So defining that objective up front is really key for us. And then again, we come into those skills that David talked about in terms of collecting data, data cleansing, before we actually start looking at kind of the feature selection, choosing the variables, and eventually coming up with a model that in this case predicted the likelihood of students passing or failing their exams. And the benefit that brought us is massive, really key. We've been trialling this with some of our big clients and they love it. So the first benefit is actually identifying risk. So identifying those students who are exhibiting behaviours and the model is actually predicting that they might fail their exams. What that allows us to do then is create timely interventions from our tutors, from our amazing staff that can make sure they're supported in the right way. And then thirdly, the actual outcome for us, we change student success. So by getting those timely interventions in, we created an environment where students were more successful in their exams. So again, a great example of how we use predictive modelling actually to become prescriptive in terms of changing actions to change an outcome. I think just from us, thank you for obviously listening to me and David in terms of what we've been talking about today.